So to solve using substitution, one of our equations has to be solved for a variable. Here, I have y equals 3x, and x plus y equals negative 32. Are one of these already solved for a variable? Are one of my equations, is one of the variables by itself? Yes, which one? Y equals 3x. So what we're going to do is we're going to substitute that first equation into the second equation for y.
So it would be x plus 3x equals.
So we're going to have x plus 3x, because we're going to substitute where y was for 3x, equals negative 32. So I'm going to substitute. That's my first step. One of the keys here is all of my variables in my new equation are the same, right? I have x plus 3x, so that we have all the same variables, so we can solve for x. So the first thing I need to do is combine like terms. Do y'all mind if I abbreviate combine like terms? So what is 1x plus 3x? 4x. All right, so now what's the last step? What do I need to do to get x by itself? Divide by 4. So if I divide both sides by 4, x is equal to negative 8. So my x value for this system, for the solution to this system, is negative 8. So step 2, to find the other variable, I'm going to substitute my answer and solve for the other variable. So I can plug negative 8 in for x for either one of the original equations. I chose y equals 3x. Why would I choose y equals 3x? Because it's given, and well, what's the missing variable that I want to solve for? Y. And this one says y equals, right? Could I have plugged it into x plus y equals negative 32?
Yes.
Yes, and I'd get the same answer, but maybe not in as few steps, right? So I'm going to plug in. So I found that x was negative 8, so I'm going to say y equals 3 times negative 8. So again, we substitute. We do a lot of substituting. That's why we call this one solved by substitution. All right. So then y equals, well, 3 times negative 8 is negative 24. So my solution, we multiply. 3 times 8 is 24. And it's a negative times a positive, so we get a negative. So my solution here is going to be negative 8, negative 24. Example number 2 says, find the solution to the system using substitution. So I have a system here. We have 3y plus 4x equals 14. Negative 2x plus y equals negative 3. All right. This example is different from example 1 because we will have to use 3 steps instead of 2 to find the solution. All right, so my first step says, solve one of the systems for a variable. Well, I chose negative 2x plus y equals negative 3 to solve for a variable. Why would I choose the second equation? Why would I choose the second equation over the first equation to solve for a variable? Well, let me ask a different question. Negative 2x plus y equals negative 3. Which variable should I solve for, x or y?
Y. X.
Well, which one will be easier to get by itself? The y, right? The y is going to be easier to get by itself, isn't it? So here, I've got negative 2x plus y equals negative 3. So it's just one step to get y by itself. So step 1, I'm going to get y by itself. So how do I move that negative 2x? By adding. So I'm going to say plus 2x. Plus 2x. So I have y is equal to 2x minus 3. All right. Once I've solved for y, I can plug that in for the y value in that first equation, right? So I can substitute. I'm going to say 3y, but instead of y, I'm going to put that 2x minus 3 plus 4x equals 14. So the first step is to substitute. Say it again, sweetie. All right, next we want to solve for x because I see all of my variables there are x's, right? Because I have 3 times 2x minus 3 plus 4x equals 14. So I'm going to distribute next. So 3 times 2x is, beautiful, 6x. 3 times negative 3, negative 9, plus 4x equals 14. We distributed. All right, next I can combine like terms. Do y'all mind if I abbreviate combine like terms? CLT. So I have 6x and 4x is how many x's? So 10x minus 9 equals 14. I'm going to need more space, sorry. So next to get x by itself, what do I need to move? Add 9. So I have 10x is equal to 23, right?
Yeah.
So finally I'm going to divide both sides by 10. So x equals 2.3. So my x value is 2.3. So step 3, I'm going to substitute that x value. So I have y equals 2x minus 3. So I'm going to replace x with 2.3. So what is 3 times 2.3? 6.9 minus 3. What's 6.9 minus 3? 3.9. So my y value is 3.9. So the solution to this system is 2.3, comma, 3.9. Would it have been possible to find this solution if we were graphing this by hand? Probably not, right? We could make a good guess, but it would probably be difficult to get those exact decimals. So in this case, solving by substitution would be the better method, right? Or we could solve for y and find the x. Exactly. All right. Example 3, I've got 2 problems in example 3. Okay. In example 3, both of the problems are asking how many solutions does this equation have? All right, so I have 2 equations. X equals negative 2y plus 4, and 3.5x plus 7y equals 14. Okay. All right, so the first thing I'm going to do is substitute and solve. So which equation am I going to substitute into the other? Are one of these equations already solved for a variable? Which one? The top one. So I'm going to substitute x equals negative 2y plus 4 in for x. So step 1. I'm going to have 3.5 times negative 2y plus 4 plus 7y equals 14. Yes, negative 2y plus 4, because that's what x equaled, right? So my first step is to substitute. And I have all the same variable. Everything's y's, right? So we got to distribute next. Exactly. So 3.5 times negative 2y is negative 7y. And 3.5 times 4 is 14. So next I'm going to combine like terms. So what's negative 7y plus 7y? 0. So that leaves me with what on the left side?
14.
So I have 14 is equal to 14. Wait a minute. I don't have a variable to plug into my step 2. But is that a true statement?
Yes.
14 is equal to 14?
Yes.
So these 2 lines are the same line. So if 2 lines are the same line, we have infinitely many solutions. Infinitely many solutions. So we don't need to do step 2 because we already know both lines are the same line. Besides, we don't have an x value to plug in. All right, B. One more like this. I want to know how many solutions do we have? It's going to be okay, Daniel. It's going to be okay. We have y equals?
3 minutes.
I do. So I'm going to pause here. To solve 3b, I see that the first equation is already solved for y, so I'm going to plug that in for my y value in the second equation. So I'm going to write 3x minus 11 minus 3x equals negative 13. So this is the equation for the second line. I just replaced that y value at the beginning. So I don't have anything to distribute, that's a 1. So I have 3x minus 11 minus 3x equals negative 13. So 3x minus 3x, those are 0, so I have negative 11 equals negative 13. Well, that's not a true statement. So that implies these two lines are parallel, so that means this system has no solutions.